So by continuing to participate, you are agreeing to be recorded. But as I said, but not all of you were here yet. I will share this with all of the people who signed up to be in this meeting, but won't send it to anyone who was not signed up to be in this meeting. So you have a view on who will receive these. So I think most of you know this, so I'm going to do this really quickly. Today we're here to talk about a public-private partnership, which means we are mixing industry contributions with subsidy money. These public-private partnerships are pre-competitive, bring together a value chain. These are requirements of the subsidy, so these are sort of fundamentals that we need to comply with when we're working on these types of projects. And these TKI public-private partnerships also include both fundamental work and translation to application. So we will very likely have at least one PhD associated with this project, and we'll have some model system application work as well. They are open to Dutch and international partners. This year, they've made it a little bit more Dutchy in the sort of call for partners. So we believe that, the more feet on the ground, the more activities we have in the Netherlands inside of our portfolio of partners, the better it will be for acquiring subsidy. But partners who trade with Dutch companies are very, very welcome, and international partners who bring something unique to the table also welcome. This project will have a PhD affiliated, so we're headed for a 4-year project. As I said, we get 50% of our subsidy financing, and we ask our industry partners to contribute in cash and in kind. The in-kind contribution is open to discussion. We will work with each one of you to find out what that is, if it's materials, if it's hours, effort, whatever. Typically, we're aiming for a cash contribution of between 30 and 40K per partner per year, so have that roughly in mind. After today, we'll do a more detailed briefing and some deep dives that will help us rough out a budget for the project, and we'll get back to you on what that amount will be, but have this in mind. And if you are a small medium enterprise, an MKB in the Netherlands, there are different conditions for you. The amount that you bring in is negotiable. A one-person company is very different than a 250-person company, even though they're both SMEs. That's why we don't have a fixed price. It's open to discussion. So if you are an SME, we'll talk it out. Yes, we'll talk it out. Once the project is going, we have a project oversight committee that governs the project. And it's important to say the goal there is that it's your project and Wageningen is one vote, and we are all collectively managing this project. The project committee also governs IP and dissemination. And my super, super short summary of a 30-page consortium agreement is ownership follows inventorship. If we protect IP and that belongs to Wageningen, all partners have the right to license that in their field, but need to pay a fair market rate, which includes returning the subsidy back to Wageningen. If you know IP is a difficult thing for your company, please give me a sign. We can talk it through exactly how this works if you want. Good. So super short summary. Does anybody have questions, like burning questions they want to ask about that? I know I ran through it this time for real, but no? Okay, great. Then I will hand over to Panos for the really fun part. Panos, do you want me to continue sharing the slides?
Yes, please.
Yeah. Okay.
Go to the next slide, please. Yes. So this project idea is about developing texture and structure for alternative cheese and focusing also on the functionality of such systems. By functionality, the name of the project is a creative alternative cheese fun or AltCheeseFun. And the motivation for this idea is coming from the problem statement. And we know that in the market, as it is right now, the current cheese alternatives rely on non-protein ingredients to develop texture, but also in functionality, right? By functionality, in that case, we mean melting, stretching, or slicing, which in another term could also use a performance of such final products. We think we can do better than this, so we can increase the nutritional quality of such products, such model formats, by introducing proteins. And then our goal for this project is to develop actually technologies for plant-based cheese to optimize the texture and also the performance of such systems. Our model system is starting from the composition of dairy cheese, and that's why based on these compositions, based on this composition characteristics, the aim also is to increase the nutritional quality of such products. You can go to the next slide, Stacy. This is a little bit the background of why we believe we can work on such topic and we can have an impact for that. We do see we have worked a lot in the past on how to structure using proteins. These are a couple of examples of previous work that we have done, accessing the gelling mechanism for different type of proteins and mechanisms for structuring under different conditions. This is one approach that we would like to follow, playing around with such parameters like pH, ionic strength, and maybe temperature. If you can go to the next part, Stacy. Another option that we think that can be used as a starting point is not only structuring from the protein materials, but also use the protein as the protein can be on the surface of emulsion droplets or can be in the form of soft particles or aggregates, hard particles. By concentrating such suspensions we have seen in the past, and also there is recent literature about that we can develop textures which are similar to, not similar, but there are texture, let's say, possibilities there for structuring with protein particles. Now, playing with the softness of such particles or with the composition of such particles, I think there is hope on this field on which we can use such approach for our study. If you can go to the last part, Stacy. So these first two parts were for the protein themselves. We know that for cheese we have to take to account the oil, fat phase. We believe that this type of technologies that have been already available, we have to use them in the form on which fat droplets or fat phase is already present in such network. So the interplay basically, what the message of the last part here is that the interplay of proteins with fat is also important. It's something that we take into account. Yes, so this is a little bit the structure of the project concept. We really aiming for plant-based cheese with optimized texture and functional performance, and goes without saying about the nutritional density. And the directions in order to achieve our goal are coming threefold. The first part is really understanding, going to the fundamentals of structure-function relationships. And then the aim, the focus will be on fat-protein interactions and how to engineer product performance. On top of that, we would like to have a different approach, and in that case, we want to use processing routes for texturization, and also having in mind that the functional performance of such formats that we would like to have. And in that case, we want to either optimize existing processes, explore new processing routes, but it can be a combination of both. So it can be that the one part that some processing steps we need to put them one after the other in order to achieve texture and performance for the formats that we are preparing. The last part is about translating the above findings in a nice toolbox, something that is usable besides the physical phenomena and the processing routes. We want to put them in a way together in order to develop a toolbox for structural properties and performance. You can go to the next slide, Stacy. So on the next slide, we will go. We have prepared. By the way, it's me present here, but there is a whole team behind this project, and this whole team includes also the university part, the group of food physics, and specifically Elke's group. This work package is mostly dedicated for that, and it's focusing on fundamental aspects and physical phenomena. The focus, as I mentioned, is on fat and protein interactions, and the main research questions that we'd like to address is how interactions between selected proteins and fat, oil, or functional oil can be altered to obtain gel type of structure with different structural organization. How also the textural parameters can be altered through the structure in order to play with the building blocks at different length scales. And at different length scales here, we mean from the molecular characteristics up to nanometer regimes, so particle characteristics, up to properties on which the phenomenology, the macro structural characteristics. Now, along with that, in order to have a performance of what we are preparing, performance, I mean, again, the melting behavior, but also the stretchability and the slicing part. For the first two research questions, we have to take into account the building blocks. And taking that into account, we want to evaluate the melting behavior of such a gel type structure that contributes either to the continuous, so the protein phase, or the dispersed phase, which is in this case the fat phase. The last part is on sensory attributes and interlinkage with the structural and textural properties. Here I have to mention is we are focusing on the sensory attributes without necessarily applying a sensory study, but the sensory study can be done on each partner on this consortium. Of course, in cases need, we can support that, and but I think the sensory part, maybe what Igor also mentioned, is can be more focused on each partner's organization. If you can go to the next slide, Stacy. Yeah, besides addressing the physicochemical phenomena, we think that through processing, we can also develop routes, meaning that can be sequential processing steps, one after the other, in order to get a texture on which has a functional behavior, like melting. And in that case, here we propose some examples on which they can have, they can deliver, let's say, such performance and texture. For some of them we have worked with, so there is insights for some of them, like the fourth one that you see here, the spray drying, is something that we have not worked yet, but we have seen studies in the past that can be a nice route. The first three I have to mention here, so gelation under stressors here, or pressure-induced gelation and extrusion, has to do with molecular or macromolecular properties of the proteins. So the first step that you see on the slide, for the reasons we believe, or the scientific basis for that, The fourth one has to do about getting a texture, a gelling behavior using particle field, preparing particle field gels. I guess there are more processing steps which are not listed here, but we are going to explore that and identify which ones are the most suitable ones. And the last part is that, yeah, a little bit again goes without saying that maybe or we have to combine different processing steps to achieve our goal. Stacy, if you can go to the next slide, please. The last part is on really developing a toolbox, a strategic toolbox for gathering all this information and providing structural properties. The first part we think we have to address is the physical mechanisms for developing such texture and structures. We need to confirm it with more experiments to see basically the applicability of such mechanisms for a broader range of proteins and fat, oil, or functional oil components. Again, the focus area is on the functional performance here, the texture formation, the melting, and the stretchability. And can be here, there is the option to explore also some more properties like, I don't know exactly how it's called, but how you pass the cheese through a grain and you get cheese that is suitable basically for spaghetti. The next part is, yeah, we want to apply the concepts of work package 1 and work package 2 to tune the textural and functional properties, having in mind always the sensorial attributes. And the last part is on really, we are aiming from this project to deliver knowledge, relationships between the type of ingredients, their corresponding interactions, and performance outcomes, also in relation with the processing steps. Yeah, I think this is my last slide, right? This is what we have prepared to show you for the project concept. As I mentioned, yeah, this you see here me, but there is a whole team behind that, and yeah, I think also through Stacy, I would like to open a discussion about what you think, have feedback about this project idea.
Can I ask a first question, maybe?
Of course.
That's about is there a certain type of standard recipe that you firstly focus on? A lot of vegan cheeses are a combination of starch, water, and fat. I think that is the model system you're focusing on in as a starting point. I assume.
The starting point is the composition of an animal-derived cheese. So matching there the protein concentration, the fat content, not necessarily the micronutrients, but this is our starting point. We acknowledge, though, that we might need later in the project to see if we need also starch in such recipe or such model system. But our starting point is really the composition of the dairy cheese. Yeah.
Okay, clear. Thank you. Yeah.
So if I can ask like a little bit more specific, which dairy cheese you guys have in mind?
We understood that one of the most interesting one is a cheese that is used for pizza applications. So I don't know exactly its name, but it's this one. I don't know.
Mozzarella.
Mozzarella, yeah.
Yeah, I think.
Mozzarella.
Yeah.
Yes.
But for mozzarella, it's a little bit like a not so strong cheesy flavor. Yeah. as a personal thinking. But it's like it's needed like melting and gelation properties.
Yes, so the hardness of the cheese is something to define. So the starting point for our model cheese is something that we can define together. Mozzarella, I agree, is a relatively soft one. Maybe that's why you saw extrusion there for the processing part, but something else. But indeed, we are aiming for a texture that is, I don't know, similar to Gouda or so, but has a nice melting behavior. Just in full transparency, for something that I mentioned, for the model system of focus, I mentioned that we heard right that this is the one that for pizza toppings. This project idea was submitted not in full as you see today, but a smaller version of it last year. The feedback that we got from TKI, so we got feedback from TKI, and it was mentioned that the budget was relatively high for focusing only on developing texture and the melting behavior, focusing only on fundamental aspects and physical phenomena. That's why today what I presented is focusing also approaches coming from processing and also developing a toolbox in order to make it more tangible.
Panos, I'm just going to jump in because I think your answer on mozzarella is also related to the discussion that we had developing that previous project.
Indeed.
But I think it's important. I mean, I think it's important to note that we will, on the model systems, we will engage with partners who are together with us at that point to define which model systems we'll prioritize. I think pizza cheese was taken along last year because it's sort of the gold standard for stretchability, meltability. It gives us really like the most challenging texture to aim for. But I think we're open to discussing, which cheese type we should go in terms of flavor and just sort of texture matching.
Definitely, yes. Thanks so much, Stacey. Yes.
Maybe one question about the execution. Of course, all that casein is a very important protein in cheese making, and it has very specific functionalities. Is it also the idea to make, let's say, the plant-based cheese in a similar way as cheese preparation and try to get the plant proteins to behave as casein? Or is there you want to totally let go of that?
Well, yeah, I think it's a very, thank you for the question, Marcel. It's a very well, this is an approach. We have tried in the past using plant-based ingredients to make structures that resembles casein micelles, but that was very challenging. One of the scientific routes that we would like to explore is using particles for that. And our approach for making casein micelles, meaning a nanometer scale, that was not successful, does not mean that we cannot make micron-sized particles. I don't want to make it too vague or secretly, but for instance, an approach, and we have seen some recent studies about that, on how proteins can have a micellar type of structure is maybe through coaxervation. And there we do get entities of proteins which are soft, spherical. They are not in the range of nanometers. And maybe, I don't know, maybe is a way to tackle this special property of casein micelles. I'm not saying that it's going to be exactly the same, but it is an approach on which we can follow.
But, am I right? Am I right in thinking you would not go through a renneting and fermentation even with those particles? I mean, it is really about.
Yeah, we would like to use for such approach, we would like to use maybe proteins coming from precision fermentation or something like that, but not apply the fermentation ourselves to make such proteins.
I think you mean it differently, Stacey. I think you mean the use fermentation to make the flavors and to acidify and to make the texture.
Yeah, exactly.
Because you can, of course, there's also initiative that people try to make casein. That's something
Exactly.
that precision fermentation, of course. Yeah.
Yeah, exactly, Marcel. You understood me. Sorry, Panos, that wasn't clear, but I mean, we're not going to go through a classic cheese making where we're making plant-based milk and then we're renneting it and fermenting it to get to a plant-based cheese, correct?
Yeah.
Correct.
So this will be a different processing route.
Yes.
No. Okay. Mm-hmm.
More questions? Yes, Igor very politely raised his hand. Thank you.
You didn't expect me not to have questions, right? Yeah. What's the rationale behind the processing? And I mean, I see a whole bunch of like grab together ideas that we can possibly do in a pilot plant, and I'd like to see how can we. What are the fundamentals of making the choices of the type of processing, including also what's the rationale for having the subsequent steps within the processing?
Can explain a little bit. We know that in plant-based proteins, processing steps are very often used to alter the non-functional proteins. So we can make particles small using processing steps, protein particles small. We can also gel proteins using heat, shear, but also heat and stress. This is the rationality behind. Though we do see options for this approach, right, for these model systems. Combination, for instance, of pressure with temperature, and pressure for plant-based proteins, coming also from studies from animal-derived ones. We do see that the gel properties that we are getting for the proteins are quite different to what we typically get from temperature-induced gelation. So we would like to play with both in order to, we know that only temperature-induced gelation will not work for this application. So we either have to combine it with something else if it has to be there, or we have to go away from it in order to deliver a texture which has a functional property. Was it clear, Igor? Or
well, yes and no.
Okay.
Some groups very close to you have been working for the last 2.5 decades on shear cell technology. Some groups next to you have been working on extrusion for the last 2 decades as well. So I'd like to hear a bit more about from how are we going to reuse that knowledge here? Because for now it starts like, well, we know we have to do something, but in a way we don't really know where to start. So let's try pressure and temperature. And I think that's too weak.
It is, yeah. Well, we have seen results on which by combination temperature and shear, but not in a shear cell environment because this is dedicated for another application. But combination of shear and temperature, we can deliver textures that we are looking here within our organization. From the processing part, we have a group dedicated to that who knows all the ins and outs about the processing steps. Have to admit they are doing that for more than 10 years, but anyway. But also very recently, combination of temperature with stress, not shear, also provides textures which are very similar to what we are looking for. The pressure part is coming literature is something that we have not worked in, but it's coming from literature from mainly from animal proteins. And in that case, the gels that we are getting are completely different. still there is a gel, but let's say the fractability, in a way, the melting behavior can be quite different to what we get with temperature.
What pressures are you looking here at Panos? And the reason for asking is, I mean, I believe you have a machine in Wageningen, but I'm not sure if it's still operational. And otherwise, there's one in Helmond where you can go, what is it, 3,000, 6,000 bars? And at
Correct.
that point, there indeed, we are looking into creating new textures where there's a lot to explore. Is this the type of pressures you're looking at, or are you looking at standard pressures we can achieve in an extruder?
No, we are looking for machinery, as you mentioned. We do have a still operational. We want to use not a pilot scale one, but almost lab equipment. And we also have the option to go to Helmond to do higher scale experiments.
I would put that much more explicit in there because it makes it much more tangible that, hey, we're really exploring new areas where we might be able to find things that we have not been able to find before. Because a lot of the other routes, or like the ones you mentioned also on the slide, yeah, well, we have all tried them a little bit. Nothing structured, over the whole area, but we never got anywhere really far. So that would make it much more innovative and appealing, I would say, if we make that explicit.
Okay. Yes, clear. Thank you for that.
I'm just going to jump in, Igor. Thank you for that. I think this reflects also a bit of internal discussion about what's in scope, out of scope in terms of processing, and a need to sort of balance that in discussion with partners. I mean, you mentioned ShearCell, for example. We toss back and forth, do we want to include 3D printing? There is a small subgroup of the team who's behind us that really want to try 3D printing cheese curd. But we also are conscious that anything that's very future forward or not upscalable in a 2 or 3 year timeline might awake resistance from some other partners. So I think that's part of the deep dive that we need to do is like, hey, what's in scope? Do we really, how future forward are we going to be with the technologies? But certainly including some of those as examples in the proposal would probably help us heading to the subsidy. So good that you raised the point. Were you done with your questions, Igor? Shall I call in?
I still have plenty, but one maybe still to put out. You said it on the fundamental level, you would like to mostly focus on fat-protein interactions. And at the same time, later on, you went on to complex coercivations, including polysaccharides. Otherwise, we don't get a complex coercivation in there, I assume. So I could arguably say, like, okay, and getting a bit more view on what the overall scope of ingredients is, what type of proteins, what type of maybe fats, of course, for upfilled also very important there, but also maybe what parts of polysaccharides are you planning to work on to create these textures?
Just mention that we don't necessarily, I didn't say necessarily complex conservates. We can get conservates only with one protein or
okay.
Yes. It will depend. Yeah, I don't have a clear answer for that, Igor. Well, it will depend on what are the proteins available and what are the polysaccharides, carbohydrates available in the project. And based on that, we want to work around that. Yeah.
I'll shut up now.
Yeah. This is probably a key topic for one of our deep dives in developing this this project content. Hey, Ewout, unknown user, welcome back.
Yeah, they fixed my settings after this morning, I understand. So excuse me for being late. I'm Ewout de Vogel from Algae for Food. We make functional ingredients out of microalgae. We're an ingredient company. We're not a microalgae company. We have we figured out we have some ingredient out of microalgae which has amazing gelation properties, especially for the plant-based cheese products. I was wondering, I'm not really interested in all the scientific work behind it, but is there a need for other sort of ingredients and other source of ingredients to play with in this kind of project? Is this of your interest, or is it really more for a later stage, my work later on?
It's a question for me, right? Or yeah.
Yeah.
I would say everything that because yeah, this is something. Everything that gels and is protein, I think, is of interest in a way. Does it answer your question? No.
Yeah, well, is that the role big enough for us to be a sort of supplier of a protein, or is it okay like that, or you need more involvement in the project?
Oh, that's less of a content question and more of a like how do we expect participation kind of question. Is that, yeah, so we typically do not. Well, the first question is, are you an MKB? Are you a small, medium enterprise or above 250?
Startups, definitely startup. Yeah.
Startup. Okay, well, in that case, my answer will be slightly different. For startups, depending on the size of the startup, the level of maturity and the sort of maturity in the funding trajectory, the contribution is negotiable. Sometimes we have ways for startups to participate only in kind. Are you a Dutch startup as well?
Yeah, based in Wageningen plus Ultra. We already have the product available, so we can deliver samples of it.
Yeah. Okay. Yeah. So don't worry too much. Like for especially for Dutch startups, in this subsidy landscape, the mode of participation is sort of open to discussion. We try to find ways to accommodate startups, and that also the level of sort of in-kind contribution is something that we can work out and discuss together. We do appreciate having some kind of in-kind contribution, someone participating in the project. So just handing over materials and being like, bye guys. I mean, Panos is happy to receive materials and the invitation to play around with it. But if we lose you, then we lose also the feedback loop and we lose, the learnings about the ingredient, et cetera. So I would recommend, for a project like this, for a TKI project, we recommend and we prefer that you join the project, you help steer the project, you think along with the project. But if you don't want to participate in a project in that way, this might not be the one for you. Just hand Panos a bucket of what you've got, and you guys can nerd out about it separately.
Okay. No, clear.
Yeah.
Yeah, clear. Good.
Okay. Yeah. Good. Vaida?
Thanks. So quite some questions were asked by Igor already that were also on my bucket, because all the parts, as for example, type of fat. Now we talk about the type of protein, but type of fats are also of interest. But what was not touched, Panos, the melting parts. So now we know that with a protein, we can get various textures. And by processing, by using different salts, we know that we can vary from elastic to brittle, stiff, you name it. But melt parts, which element you think the melt part will come from, or which element we would focus to obtain the melt?
Yeah, for the melting part, well, if it is a texture that contains starch, yeah, the answer is easy. But for this context, I think the texture that we have to develop, we have to have in mind that upon a temperature step, it should melt. So we have to design the texture as such in order to achieve that. Let's say with the traditional way, which is mostly this temperature-reduced gelation, we know that the texture can be correct, but then the melting behavior will be the other way around.
Indeed.
So that's why the texture we want to decide, we have to take into account the melting behavior. That's why you saw slides on which the gelling step, we want to do it through other ways. Pressure, for instance, from a processing perspective, through particles from another perspective. So we have to have in mind this functional, let's say, performance of this piece to first to develop the texture. It is the other way around in a way.
But so Panos, so if I can summarize, you still the focus would be really on the protein part and to somehow figure it out. Can we have kind of heat reversible protein, that it can gel, but also upon health, kind of a gelatin-like of behavior.
Yeah, well, for gelatin is a different thing because it's not only the reversibility of the gelatin, the gel that it makes is transparent and all these other things. But we want to develop a texture on which design a texture and develop it, which upon heating it will melt, it will fall apart. So the network of protein should fall apart upon heating. The fat protein interaction, I think in that case, plays a very important role on how to design such texture. And yeah, the type of oil, if it is oil, if it is fat, I know there are options for functional fat are more than welcome here to address.
I saw that Igor put a reference in the chat from our colleague Guido Sala. Guido is one of the, from Food Physics, he's one of the involved experts in helping.
Exactly, this is, and as well, I mean, this is more to show like there is already quite a bit of knowledge in food physics around this topic. That's also the reason why I would like to continue this and towards less starch, more protein-based systems and see what can be done there. That absolutely increases the credibility of the project.
Thank you. Dinah, another question?
No, that's it.
Anyone we haven't heard from yet who wants to jump in and ask the last question before we look at timelines?
Well, it's for me, maybe as a comment, if we see how many things are proposed and fundamentally how many things we the project would like to tackle. And if I'm not mistaken, we discussed or you proposed Stacy, one PhD student. And timelines, of course, I mean, everything in there depends on the final setup, but between 2 and 4 years, it looks quite challenging.
Yeah, I think you're completely right. Panos and I were just discussing before we opened the call if it's 1 or 2 PhDs, which depends also on the size of project we want to go for. And I think I agree with you. There's a lot there. So priority setting in our deep dive conversations with the interested partners is going to be a really important way of scoping this out. I will say, well, we might have gone a little bit far in that direction. I will say last year, the project that we applied was heading close to 3 million, and we were exclusively focused on sort of melting behavior and understanding the fat structure and the fat protein structure. And the feedback that we got was it wasn't ambitious enough given the size of the budget. So I think what we've done here is put down something really ambitious. Just to be sure we are not getting that feedback. But I think you're right that we're going to need to do some priority setting in the next couple of weeks because Panos and the team have a lot of ideas.
I think looking really from industry point of view, always 4 years when we propose internally, it seems forever. So we always want everything right here, right now. And of course, if I see timelines 2 years, that looks much more appealing. But also understanding the field and understanding the challenges, you always also try to, you know, to cover different angles, what is realistic, what we want. But definitely the topic is very relevant.
Yeah, the issue that we have with, I mean, if we choose for a 2-year project, we can't have any PhDs, and PhDs are a cost-effective way to get a lot of work done. So, I mean, what we can always do is have a set of milestones and deliverables which are due after 2 years, if that helps. But if we decide not to have any PhDs and go for a 2-year project, it has to be scoped in a different way because we, you know, just looking at, you will remember from your PhD, get a lot of publications out of a PhD. Yeah. All right. So I'm going to very quickly go through the timelines. These are the same. So if you've been in more info sessions, you will know them. So I've mentioned them already. What we will be doing in the next few weeks is doing some deep dives to co-create the project content. So if the project feels like a fit, if it's a topic you would like to be working on, I would really, really, really appreciate if you could give Panos and his group a half an hour of your time, or maybe 2 hours in small groups if that's possible. To sort of dive into the content, challenge the content, help us make some choices, help us prioritize. We want this to be a co-creation so that the project is really sort of aligned well with your needs. I will ask you to respond to me. I will send out an email with the slides, the recording, link to the recording, and I will ask for a response on whether you want to be involved in that process. By the end of July, we have to do a go, no go for projects. So I also said this in the last meeting. What is really difficult for me is if you ignore my email. What is really helpful is a yes. Also really helpful is a no, this is not a fit for you. That's very clear because it helps us get a good head count. If neither of those is an option, just an email back like, hey, it's a maybe, but I still need to align this and that internally. Please do that because it helps me know you're still alive and you're still thinking about this project. Deadline September 1st. Most of you know how this works. 6 weeks later, we get approximately 6 weeks subsidy grant notification. Then we go into the contracting, which is always longer than we hope it's going to be, and kickoff will be around about the end of Q1 2025, all things going as planned. Good. So short term, most important thing, please let me know if you please consider volunteering to support developing this project, and I will send around the information. And with that, I think we are done, unless there's anyone with one burning question or comment. 2 minutes ahead of time, which is great. I'm setting a record. All right. Thank you, everyone, so much for joining, and we'll be in touch.
Thank you too.
Thank you.
Thank you.
Bye-bye.
Thank you.
Have a
Thanks
good
a lot.
evening. Bye-bye.
Talk to you
Bye.
soon. Bye-bye.